So good morning to all of you. I welcome you to this lecture on big data analytics. Today is the 12th lecture. In today's lecture, we are going to discuss about eval functions, string functions, date functions. We'll be discussing the pig architecture, like how the whatever scripts you pass to pig, how they are executed. And we'll be discussing the case studies based on emp and department and on movie review. I've already sent these to you for solving. So I'll be picking up a few queries and we're discussing with you. And obviously a few polls would be there just to see that you are, understanding whatever we are discussing here. All right. So let's begin. Eval functions we have already discussed, but since they are important, you'll be using them a lot in your queries, like the data sets that I have given. And one data set you need to work on your own, right? So how many of you have found that data set? You can raise your hands for the part B of your, and be sincere in answering, not just raise hand for the sake of raising it. If you have found the data set, okay, Narinder and Mridul, two people only. All right. The rest of you find the data set, and after that, you just need to write a few queries for that, 15, 20 queries. You're already writing a lot of queries. So that would be a sort of a revision for your entire, Apache Pig, so that you can write the queries and find a good data set, one which contains some date fields also. Don't pick up a data set without a date, right? So eval functions, they are usually, performed after the relation has been grouped, after the relation has been grouped. So grouping is the first thing for eval functions to work. So let's go to our terminal and start the distributed file system services. Your second sessionals are also coming, so kindly review the things that we have learned, and you can watch the videos that have been posted on my channel. So once the services have started, I can start pig in MapReduce mode, right? I'm starting pig in MapReduce mode. So now here is the grunt shell. So I'll load that emp data set. Okay, it's in the root of the distributed file system. We can check. You can see that m.txt is present in the root of the distributed file system. I load it into some relation. It's a comma separated values file, so I'll use this pig storage and the separator as a comma. And then I'll give some columns, say 8 columns are there, so I'll give that A, B, C, D, E, F, G, H, 8 columns, okay? So once loaded, I can dump the relation to see the contents, what the data set or the file contains. So as usual, you'll see some records there. So I have added 2 more records for some function discussions that I need to go with you. So 14 records are there in the original emp dataset. 2 more I've added at the end. You can see them with emp IDs 1, 2, 3, 4 and 1, 1, 1, 1. Okay. So let's group this on department number. Okay. So that we can, work quickly as a revision for all these functions. All right. I'll just work with a few so that things are refreshed in your mind. So I'll write here B is equal to group X by department number is the last column, so by H. Okay. So if we dump this, let's see how many groups are there. One is department 10, 120, 30. One is a null. Let's see if there is any other group. So both the records I have given the emp number as the department number as null. The last two records, so they are in the null group. Now we could have a query to find the total number of employees department wise along with maximum salary and average salary. So I want to see that how many employees are present in each department. I also want to see the maximum salary and the average salary department wise. So I think somebody of you, out of you can help me with this. Raise your hands to answer this, please. Yeah, I'm waiting for your response. This is a schema for X. Yeah, I'm waiting for your response. We have already discussed this thing. Okay. Kushpreet, you can unmute yourself.
Good morning, sir.
Good morning. Kushpreet, can you answer this query?
Sir, please repeat the question.
But didn't you hear it first time around? I called it twice. Okay, let's ask Narinder Pal. Narinder, you can unmute yourself.
Hello.
Yes, Narinder.
Good morning, sir.
Good morning. Yeah, answer this query, Narinder.
सर मैंने सुना नहीं, नेटवर्क इशू था थोड़ा.
All right. We are living in a technological age and we are having network issues of even listening, leave aside the video part. That's very surprising. Let's hear from Mani now.
Yes, sir. Actually, I also missed some part of the query. I know actually the count of the employees department wise, and further I don't know.
Count of the employees department wise along with the maximum salary department wise and average salary department wise.
Okay, sir. Sir, first we need to group it.
We have already done it.
Oh, okay, sir.
The relation is B.
Okay, sir. Then, sir, for each B, generate, count. So group we can also generate to group column. Sir, count amp. Sir, department wise. Sir, amp dot department number.
No, when you're counting it, you should write M dot department number.
Sir.
ठीक है, लिख देते हैं.
And then, sir, average function, max function.
Average में क्या लिखूं?
Average, sir, marks. Oh, sorry. Average, sir, cell.
Yes, Ritika. You guys are not attentive. What is the fun of, discussing these queries? Ritika, you can unmute yourself.
Yes, good morning, sir.
Good morning.
So R equals to for each B, generate group, count X, comma, average. So count X only.
Okay. Average?
Average X, comma, salary is E maybe. X dot E.
Is F, I suppose.
FG.
Yeah.
F.
Okay.
X dot F, comma, max, X dot F.
Okay, let's dump. Let's see whether we get what you've suggested, Ritika.
Yes, sir.
Right. Okay. So count will count the group wise, count, it will count all the things in the group, and average and max will do their jobs. Okay. So kindly have a look at this query. Now, this is how you can summarize information out of a group. The word group would mean the column on which the grouping has been done. So that is the department number. Automatically 10, 20, 30, and a null group is there. Okay. Then the difference between count and count star is also important. Where to use count, where to use count star. So wherever we don't wish to keep the null values in picture, then we can use count. Count is, count star would count null as well as non-null values, whereas count counts only non-null values. Keep that in mind. And max, min, size, concat, all these functions you have done. So let's begin with the string functions. So we have the following string functions. We'll be discussing these: ends with, starts with, substring, equals, ignore case. We have discussed some of them previously. So let's have a review of all of these once again. So what about these functions, ends with and starts with? What type of functions are these as compared to substring, index of, last index of? So difference here is that some functions are returning Boolean values, that is returning true or false, whereas some functions are returning some values, right? So that would be deciding how to use them. So ends with and starts with should be used with your filter operator, whereas since substring, index of, last index of, they are returning values, so they should be used in projection with for each. Okay. So let's see the usage of starts with. So starts with and ends with, they have two arguments. There is a string, and you want to check that whether a string ends with some string that you mention as a second argument. Okay. And starts with is the same. So let's check these. Let's check them on our emp table itself. Okay. So let me just modify the schema for this, the load function for this. This B is ename, so I will give it as a char array. C is a job, I will give it as a char array. So if I now describe X, I can see the modified schema, okay, where I have specified B as char array and C as char array. So I'll use a filter function, filter operator. C is equal to filter X. So obviously for these string functions, you don't require any grouping. Okay, grouping is only when you want to work with eval functions. All right. So filter X by, and then the function starts with. You can give some column here, say B. You're checking whether a name starts with something. Okay. So I can write this. So I'm trying to filter out the records in which the name starts with the letter S. Okay. So let's dump this and see how many records in our M table end with the letter S. So there is a Smith, there is a Scott, there is a Sanjay. You can see that. Okay. This was the query. We are filtering the relation X by, comparing the column B, that is our rename, and the function is starts with. So we are checking whether our name starts with S or not. So there are three entries in the M table in which the name starts with the letter S. Okay. So if I write this query, obviously you know the answer, that this string comparison or string matching is always case sensitive. So if I write this, then this is not going to return any values because there is no name with the starting with a lowercase s. Keep that in mind while you are So no records are written, nothing is found. Okay, no record is filtered. Same you can check with ends with. You can check with ends with, say, job, and you can write here man. So I'm looking for all jobs that end with the string man. Okay. So if I dump C now, you will see all the salesman record being displayed on the screen. Okay, so all the salesmen, this was the query that I did, right? Then you can combine this also, like all the salesman record, and you can put an or here. You can write starts with, then you can compare, you know, out of all the salesmen, the one which have the name beginning with A. Okay. So if I write this, okay, how many records will be returned? See, look at the query on the screen. You've already seen the result of the previous query, which was ends with C, comma man. I've added something to it. Now this query, filter X by ends with or starts with this, how many records would be returned? Raise your hands, please. This query would return how many records? Shaurya Sharma wants to answer. Okay. Yes, Shaurya, go ahead.
So one record.
Shaurya, be careful. You've answered too quickly. I also thought one. Look carefully. One would be the obvious answer that comes to our mind. Okay, we'll take one as your answer, right? Let's hear from somebody else, you know. Okay, Ritika, you can answer.
So I need to see the complete table. It will be 4 plus
Yes,
some
good.
more record.
So all these 4 records are going to come because there is a or condition. Shaurya, can you see? There is a
Yes, sir.
or. So both the conditions will go simultaneously. It's not an and. If it would have been an and, then maybe, you know, and then Ritika is right. We need to see the entire table to see whether some name starts with A or not. Okay. Right. So we have just seen Ellen here. We don't know others. So let's see what it returns. Oh, it's Ajay is there, Adams is there. Okay. You see, salesmen all would come, and along with that, all the names which begin with A will also come. Okay. And Shaurya, you can answer again. I'll unmute you. I'll just put a query for you so that it's clear to you. What now, Shaurya? Now you've seen all the records. What do you think the answer is now?
So now it's 3. Alan, Ajay, and Adams. And all the salesmen, including.
Again, you're not focusing.
So starting with
Now both the conditions should be there, right? Both the
and आपने लगा
conditions.
दिया so.
मैंने
It's
and
only
लगाया.
3 records.
Which 3? Please tell which 3.
Alan, Adams, and Ajay.
Okay. Upinder, what do you want to say? Unmute yourself, Upinder. Upinder. Unmute yourself, Upinder. 274. You've raised your hand.
Sir, one answer.
Yes, Upinder.
One answer.
Only one. Which row? Which record?
7499.
7499. Okay. Seems the correct answer. So I'm just revising the and or with you. So you should be very clear about, you know, combining your conditions. Good answer, Upinder. Thank you. So that way, you know, you can use the functions. We are using string functions, and we see the first category ends with and starts with. So they are, you know, they will either return a true or a false value. So such functions should be used with. filter condition, filter operator. And see that the usage that they need to be written in all caps. Functions, they need to be written in all caps, and certain functions will have the first character of every word capitalized. Certain functions will be connected with underscore. So a lot of variation is there. Just keep that in mind while you are using the appropriate function. So let's next use substring. Okay, let's use the substring function. I'm discussing these functions with you, reviewing them again and again, because a lot of queries would be, easily handled by these, with the combination of all these functions. So let's use a substring query on relation X. So since substring is going to return something, so we need a projection. So for each X generate, let's generate the name along with its substring, some substring out of the name. Okay. B comma, say, let's say 2 comma 5. Okay, and we will just check whether we have understood this thing. I'm from the relation X, I'm going to generate the column B, that is a name, and a substring out of the name starting from index 0, going on till starting from index 2, going on till index 5, and 5 index is not included. Okay, 5 is not included. So if I dump this output now, you'll see both the columns, the column B and its substring, so that you are clear how this substring works. You can see Smith, so it begins with I here, the substring, because I is at index 2. The first index in a string is 0, so it's 0, 1, 2. Okay, and then I've said till 5. Okay, so you can just check, you would be able to check it. Names are short, so let's use a C here. Let's use a C here. We will use the job column to check this substring so that we are clear about it. So you can see salesman, that would be a clear indication. Salesman, it's 2 to 5, only 3 characters it is picking. It is not picking M of salesman. That is the 5th index. Okay. So remember this query, the index, the final index is not included in your substring. It is one character before the final index. Keep that in mind. Okay. So can we use this substring for a query like this? Like the one we use, like we can we use for all the records which include, or all the jobs which include the string man? Can we use a substring for it? Please answer this. I want to write a query which displays all the jobs which have the character, the string man in it. Could be anywhere. So can we use a substring for it? Yes or no? I just want an answer, yes or no. I'm not going to ask you for a solution. Can we do it with a substring? I'll come back to it later, right, today. So you just think it over, whether we can use this substring to find all the jobs which contain man anywhere in their strings. Okay. Next is equals ignore case. So 2 strings are there. We are comparing those 2 strings and we are ignoring the case. Okay. We are matching 2 strings, but we are not considering the case in them. Okay. So again, this would return either a true or a false. So we need again a filter condition. So we can write filter this. See how we write equals ignore case. You can write something like this. So I'm comparing the job column, that is a C, and I'm filtering the rows, tuples, which contain the string salesman. Now you see in actual relation, it's in all caps, but it will compare and will return all the salesman rows because we are using a function which ignores the case while searching, while matching. So if you dump here, again you will see all the salesman record. Fine. So you see the usage of equals ignore case. Next we have the last, the index of and the last index of. Okay. So index of function has 3 arguments. One string from which you want to extract the index of some character which is present in the string. If the character is not present, then it will return a -1. So index of has 3 arguments: the string, the character, and the start index, like from where you start looking for that character within that string. Okay, so let's use this query. What would be we be using for this, a filter or a for each? Kindly reply. To check the index of operator, do we require a filter or a for each, or both can be used? Kindly answer this question. Can we use a filter with this? Waiting for your response. Okay, Money, you can answer.
Sir, it will return the index value. So I think it will not be used in filter, because filter will be used whenever the Boolean value is there.
All right. Yes, Ritika, you can answer. I'm looking for a different answer actually. Yes,
So
Ritika.
same answer, that filter can't be used.
Filter can't be used. Okay. Okay, let's have a query. I want to use filter. You both of you are saying we cannot use filter, है ना? Because initially I started my discussion with that usually the functions which are returning true or false should be used with filter, and the ones which are returning some values with the for each. And now I am asking the same question, and I I I want to vary on this actually, because this is something which all of you who are good programmers would answer automatically. Okay, see how. Let's use the relation D filter. I'm going to use index of. Okay, filter. See, index of C, comma, index of C. Can all of you hear my voice? Just give me a raised hand. I had some network issue here. Okay, all right, fine. Thank you. Filter X by index of C, and look for the index of L. Okay, in job, index of L in job. So I'll write here a capital L and say starting from beginning, starting from 0. I'm using this index. Okay, so what is the index? Please tell me. What is the index of L in job? So obviously, if there is a salesman, okay, so it is 0, 1, 2. Okay, it will return 2. So you can match it with 2. Why can't we write this filter? See, index of is returning something. So in your filter, you can match it with something. Okay, and if you now dump this relation D, see what the answer is. I hope Mani and Ritika especially, and all of you have understood that by default, you see, if you are just matching just on, just on true or false, then you can use filter for each interchangeably. I can use for the for each also. Let's use the for each. I hope you have understood. Here this filter will check the index of CL0, right? So that is, you can see, is 2. So you are matching it with 2. So all those rows which return 2, they'll be displayed. Okay. Understood? Ritika and Mani, you can raise your hands if you have understood, like you answered it differently. All right, thank you, thank you. So let's use another one. Let's use another query with starts with. Okay. So let's see whether we can use it with a for each. So for each x, generate maybe we have some problems here, but let's see. Generate starts with b comma a. I'm trying to generate this. Yeah, we could have some problems here, but let's hope. Let's see what it says. See the answer now. We can use it, but it won't be meaningful. So it will match, it will check each row whether it starts with, because it is going to return true or false. So it is telling you. So you can also, pick up B here so that you are clear whether the query is returning the correct things or not. See now. So the query was whether the name starts with A or not. So Ellen is true, Ajay is true, okay, Adams is true. So you understand that these they can be used with any of this thing, any operator in pig, but we should see the relevance also. Okay. So let's now next discuss another one, last index of. Okay, the last index of, it is separated by underscores. Okay. Let me use it with a projection. Use job here. Last index of, and index of has 3 arguments, last index of has 2 arguments. Okay, so last index of C comma A. Okay, remember I'm looking for the last index of C, so it will be looking from backwards. Okay, but index would be calculated counting from the beginning. That is what the definition is, if you remember. Okay, so let's see what it displays now, so that you can understand how last index of works. Wherever the character is not present or the string is not present, it would return a -1. So in salesman, you can see there are 2 A's. One is at index 1, one is at index 6, and it has returned index 6 because it would be looking for the last index of A starting from backwards. So starting from backwards, you can see A adjacent to N, and its index is calculated counting from the beginning. That is how it works. Okay, I hope I made my point clear to you. This is how last index of works. Now there are functions LC first, UC first, upper, lower. Let's discuss these 4. Can somebody out of you can quickly tell me what it means? All these 4 functions, they are on screen. LC first, UC first, upper and lower. You can raise your hands to answer this question. Yes, Mridul, you can answer. Mridul, you can unmute yourself and answer.
So, sir, LC first and UC first, lower and upper, the first letter of the string, and upper and lower, uh,
So
all
what are these? These are conversion functions?
Yes, sir.
Okay, fine. And upper and lower are the same. They'll convert the entire string into either uppercase or lowercase. Right?
Lowercase.
Okay,
Yes.
fine. Let's see, Mridul, whether you are correct or not. Let's use them on this M table itself in one query itself. So say it's for D is equal to for each X generate, say LC first. Let's pick up the name field, LC first B, UC first B, lower B, and upper B. Okay. Let's dump D and see whether we get the same results that you are suggesting. So we see the output, the tuples, and you use 4 functions. So see Smith, which was in caps, LC first makes the first letter as lowercase. UC first keeps it as uppercase. Lower function makes it all lowercase, and upper function obviously would make it in uppercase if it is in lowercase, right? So that's a good answer, Mridul. Thank you. And next is replace function. Okay. So replace function takes 3 arguments, 1 string. Okay. And from that string, we specify what needs to be replaced with what. Okay. So replace string comma old char comma new char would mean that replace the second argument with the third argument that is specified. Okay. So let's check this now, and then I'll ask you one question related to it. So I'm writing here R is equal to for each X generate B comma, okay, just take, let's replace, let me just see first the row so that I can form a good query for you. All right, I'll target column C. Okay, so D is equal to for each X generate, I'm going to use replace C comma, and I'll replace say M with T. Okay, so I want to ask you whether, see, manager has 1 M. Okay, and the last record I've put on purpose, MAM TMT. So would all M's would be replaced, or only 1 M would be replaced? In the last record, you can see MAM TMT is the job. So Rahul wants to answer this question. Yes, Rahul.
Sir.
हाँ जी राहुल बोलिए.
Good morning, sir.
Good morning, beta.
Sir, it will change all.
It will change all. Yes, that's what I also think. Let's see it. So it replaces all the occurrences of that character. We are taking a character, okay? It could be a string also, right? So we are taking a character. It has replaced all the occurrences. Let's now take a string, okay, to see how it works, the replace. So I'll write the same query now. I'll replace now so let's see how it picks up salesman. Yeah, actually we don't have a good data set, na, bigger one. So manager में भी होगा ना. Let's see now. Yeah, let's see the changes that it does. Salesman and manager, these records would be replaced, salesman, yeah, saleswoman and manager, right. So when we have a, it can be anywhere, the string that you are, specifying, it could be anywhere. So that is the interesting part in it. So we may get, when we have a big data set with hundreds of records, we may get different answers there. Okay. All right. Then the trim functions would replace the spaces, all the trim functions. And your this string split would, if it is a multi-word string, and you give some expression on which to split that string, it would do that. Okay. let's use this trim and L trim. So can we add a record in our file? Let's add up a record here. Let's put some spaces in this name, Sanjay in the beginning and Ajay at the end. Okay, I put some spaces in Ajay at the end and Sanjay in the beginning, right? Let's see how it behaves here. We are using a MapReduce mode, so we must put it in our HDFS also. I'll force its entry there. That's done. So let's load the relation again. Let's look for our load statement X. Yeah, this is the one. Let's load X. Let's dump X. We'll see the spaces now in two records, trailing and leading, that we have put. Okay, you can see Ajay has the trailing spaces and Sanjay has leading spaces. So let's use L trim first. Okay, so we can use something like T is equal to for each X generate an L trim on name. That would be just one argument. Let's check. Yeah, one argument is there. So what I'm saying is wherever there is a leading, space or space on the left, okay, it should be trimmed. So let's see whether we see a Sanjay as a normal record without any leading spaces now. You can see Sanjay now. Ajay is still having trailing spaces. So you can try a R trim here for that. So you see Ajay as a normal string without any trailing spaces. Now Sanjay will have leading spaces. So if you want to get rid of all, just simply use a trim. So now we'll have a normal strings without any leading or trailing spaces, right? So this is regarding your string functions. Now we have the date functions. Would be interesting to discuss the date functions because extracting information out of, okay, somebody has raised hand. Yes, Prameet.
Yes sir, good morning sir.
Good morning, Prameet.
सर एक्चुअली आपने एक क्वेरी बताई थी जो सबसे पहले सबस्ट्रिंग की यस सर, वो उसको हम इंडेक्स ऑफ जैसे आपने किया मैच करके वैसे कर सकते हैं?
You're asking, you're answering my query or you're asking your own question? We did this actually. Let me just put it in front of you. This one we did. Are you asking about this?
Yes sir, yes sir.
Yeah, we can do this. See, index of is returning something. So ideally
Yes.
it should be used with, if you are interested in just looking at the indexes, looking at all the indexes, then you should use a for each generate. But if you want to extract rows, which, in which the index is a specific index number you are looking, then you should obviously filter and
Okay sir.
match it there. You're filtering and obviously index of CL is returning something and you are matching it with 2. So all those rows which have the index of L at second position will be returned. So if we do it here, see, if we do it here, if I dump T, I'll show the query also once the answer comes. This was the query. So in job, wherever the index of L is 2, all those rows would be returned. So you can see in salesman, okay?
Yes sir.
Clerk is not returned. Kindly check. In clerk, the index of L is 1. So that row is not matched here. That is why clerk has not come. So if I just, repeat this here, if I just write it like this, index of C, comma, L, okay, comma, starting from 0, equal to 1. So I'm saying, yeah, just let me put an OR here. So I'm saying go check the index wherever the index of L in the job is 2 or 1. Return all those rows. Okay. So you can expect a clerk entries now also being displayed. All right. You can see the clerk entries
Yes.
also there because it is also satisfying this query.
Okay, sir.
All right.
Yes.
ठीक है, okay. So let's now discuss the date functions. I say they are interesting and important because you see you can extract so much information out of a date. Okay. But before I do that, let me just quickly discuss some arithmetic functions with you because I think you already know them. But let's see, have a quick review about the arithmetic functions. See the arithmetic functions in front of you now. Most of them are, like all of them are similar to whatever you've learned in C, C++, Python, Java. The idea would be the same. For example, absolute function would return the absolute value of an expression. A cos would return the arc cosine and so on. So I'll just discuss say, the ceil function that we have used. You remember in the ceil function, we have the value of the expression rounded up to the nearest integer. Okay. And similar to a ceil function is a floor function. Okay. So you can use some generate here, use it on emp itself, use it on emp itself. For each x, generate ceil So what would be the answer here? Can somebody answer? Two questions I'm going to ask. What these functions ceil and floor would return, number one, and how many rows would be returned by this query? How many rows would be returned by this query? You can raise your hands to answer. Two questions are there. What is returned by this query? What values for ceil and floor functions that we have used? And how many rows in total would be returned by this query? I thought that arithmetic functions would be very easy. Aren't they? Is somebody going to answer this question? Okay, Mridul wants to answer. Yes, Mridul. Mridul, you can answer.
Sir, all rows with the ceil 3 and floor 4.
Okay. Let's hear from somebody raise hand. Raise your hands again. Ritika raised hand. Parth raised hand. Do you want to answer, Ritika and Parth? You can raise your hands, please. Nobody's answering now. Okay. Yes, Parth.
Sir, it is the same answer.
Ceil 3 and floor 4?
Yes, sir.
Okay.
No, sir. Ceil 4, floor 3.
So ceil is the ceiling. So it will return, both of them will return an integer, but it will return, ceil will return an integer, which is on the higher side, and floor a lower value. So we'll
Yes.
have 4 and 3 as the answer in 16 rows. Okay, 4.0 and 3.0 because they are returning a float value. Okay, an integer value, but the resultant is a float. Try to understand that. Okay, the return value is of type float, but the value would be a integer value, 3, 4, 5 like this. Okay, all right. Another look at some of the functions maybe. See, you see the list of functions. The round function is there. The random function is there. We already discussed this random when we were discussing the sample operator. So let's see round expression. Let's see whether how many arguments it takes. Let's use a round here. Round, say 23.6789, comma 2. Okay. Maybe it takes just one argument. Yeah, it seems round takes one argument. Let's check it online. Okay, it takes one argument only. Fine. So let's dump our, see the query on screen, around 23. So it should be 24 as the answer. Let's expect a 24 as the answer in round. We don't have the privilege to give up to how many places. Okay. So this was a query that I wrote around 23 points. So it's rounded up to 24. Okay. So let's have a quick poll. Easy one. The poll is in front of you now. Answer quickly, okay? You can answer, all of you can answer on your own. No need to ask anybody. We just discussed this. Closing the poll in the next 5 seconds. Please answer quickly. I'm sharing the results with you. 96% of you are correct. True is the correct answer, right? Okay. So now I'll be discussing the date functions with you. A long list of date functions is there. But before that, let me just discuss the pig architecture with you. Something that we've been doing for 5-6 weeks now, working with the pig queries. But let's see actually what is the architecture of pig. Okay. So what happens is, like whatever pig script you provide to Apache Pig, internally it is converted into a series of MapReduce jobs. Okay, and that's how the programming in pig is easier for programmers, because you don't need to go through the complex MapReduce code. Whatever you write in pig is converted into a series of MapReduce jobs, and then which are executed in parallel, and the results are stored in the HDFS. So the architecture goes like this. This is the architecture of Apache Pig. You have the pig Latin scripts, that is the code that you write, and you submit it in your grunt shell, which goes to the pig server. And then a parser, an optimizer, a compiler, and an execution engine do all the needful that is required to analyze the scripts that you've written and generate the analyzed information. And MapReduce is the thing that is responsible for taking up all your task of executing the pig Latin scripts, and the results, obviously the files that are there in the HDFS, the final results are also stored in HDFS. Let us now look at the working of each one of these, what all they do. Once your script is submitted to the pig server, then we have at the first stage is the parser. Parser does the syntax checking for you, whether there are any syntax errors in your script or not. It does that. It does type checking also. Okay, so it does syntax checking, it does type checking. Okay, so you can see the working of parser, and any other check that is required to guarantee that the script is perfectly okay. Okay, so parser is basically checking your pig script, checks the syntax, does the type checking and other miscellaneous checks. And once everything is fine, the parser, converts your pig Latin script into something which is known as a DAG, a directed acyclic graph, which represents the pig Latin statements and logical operators. So whatever statements you have written, whatever operators you have used, they are converted into the shape of a directed acyclic graph. Okay, and the logical operators of the scripts are represented as the nodes, and the data flows are represented as edges in this DAG. So remember, the first step is the parsing. The parser does it, and it does this type checking, the syntax checking, and all other miscellaneous checks that are required to check whether your script is all right. If it is so, then it is converted into something which is known as a directed acyclic graph. In the graph, the logical operators of the script are represented as the nodes and the data flows are represented as edges. Now this DAG is passed to the optimizer, okay, and which carries out something known as projection and push down. Okay, it carries out the logical optimizations such as projection and push down. Then the output of the optimizer is passed to the compiler, and the compiler compiles the optimized logical plan into a series of map reduce jobs. So compiler converts your pig Latin script, which was converted by parser into a DAG and then optimized by the optimizer. Compiler converts it into a series of map reduce jobs, okay, which is then sent to the execution engine, okay, and the jobs are submitted. These jobs, whatever the map reduce jobs they have been converted into, they are submitted to your cluster, Hadoop cluster, HDFS, in a sorted order, and these are executed on Hadoop, producing the desired results in your HDFS. Okay, so that is the working of the architecture of your Apache pig. Okay, so a simple topic, because you see nothing of this you can see actually. Some of it we can see in our next class when we discuss certain other operators which are left. There we can see some part of this happening actually. Okay, but then it is more of a theoretical concept. So I think that's the only discussion that is required about this architecture. This diagram explains it all. All right. So let's have some polls now based on this. Another poll is coming your way. You can answer it now. Answer it fast. Closing the poll now in 5 seconds. Sharing the results with you. We just discussed parser does the syntax checking, the type checking, and all the miscellaneous checks. So all of the above is the correct answer for this. Okay. Then another poll for you. Let's see. Yeah. The poll is in front of you now. Closing the poll in the next 5 seconds. sharing the results with you. Obviously, the logical plan is, converted by logical optimizer into projections and push down. It is optimized by both A and B, projection as well as push down. So the correct answer is both A and B. Okay. So this was regarding the pig architecture. Let's now discuss the interesting part, the date functions. Okay. Let me just list the date functions for you. Yeah. So we have a date and time functions. Actually, in our discussions, we have been dealing with some data sets, some small, some big, but we haven't worked much with date and time functions. Okay. So let's work with them. For this, I have a file here with me. I'll just display its contents for you. I have this file. Okay. I have a data set, short experimental data set, in which I have two fields. One is the serial number. The other one is the date and time. You can all see it. In the date, the year is first, then the month, and then the date. Then we have the time. Okay. Time is in 24-hour format, as you can see. Okay. So let's first store this data set into a relation. Okay. And then let's see how we can use all these date time functions that are listed here. Quite a big number of functions here. Okay. 21 functions are there. Nothing to be worried of. They're very interesting, each one of them. Then you must see how to use them. So I'm going to load it into a relation, say Z. This data set A1. Okay. So I can write here load. This is present in my distributed file system also. It is a comma separated values data set. So we can write here this. And then I can give two field names as SNO for serial number and say DOB for the date. And as you can see right now in the data set, it is simply a string. It's a char array, right? We need to convert it into a date so that we can do the date arithmetic on it. Okay. So SNO int like this. So if I just describe Z, you can see, and if I dump it, then you can see the output here. But right now, this is just a serial number and a char array. There's nothing related with it as a date. Okay. To get meaningful extraction out of it based on date, we must convert this column, DOB column, into a date time column. Let's see how we can do it. There is a function known as toDate. Okay, there is a function known as toDate. Right now here it is showing toDate should have the argument as milliseconds, right? But that's a float argument or a double argument. But we don't have a float or double argument. We have a char array. So you can see that there are other alternatives for this function as well. So you can give toDate and ISO string can be given. ToDate a user string comma format can be given. ToDate a user string comma format comma time zone can be given. Okay, so these are all the variations of this ToDate function, which would convert some information that you have into a date field. Okay, so I'll be using this one. Okay, I'll be using this one with you. ToDate user string format. Okay, so let's write one query based on it. Say D is equal to, I'm going to project the relation Z into a new relation D, in which my DOB column of relation Z would be converted into a date. Okay, so for each Z, generate SNO, comma, I'll use DOB also. I'll generate these columns, and then I will convert using the toDate function. So toDate, T capital, D capital, toDate. Then the format is user string. Okay, first I write the string which needs to be converted and the format in which it needs to be converted. So I'll write here toDate, then my string is DOB, and then the format. So let's say right now the format is year first. Okay, I can do it in any format. I'll do it like this: y mm. And then the time in 24-hour format. All right, like this. Okay, I can give this. This is a a pseudo column sort of. This field is not there. It's a projected field, so I can write something like as dt1 colon the date time data type here. So just look at this. I need to close the string here, I suppose. Yeah. Okay. So I'm from my relation Z, which contains two columns, serial number and DOB, which is a char array. I'm generating a projection for it in a relation D, which contains the two columns SNO and DOB, as well as a third column, which is the DOB converted into a date in the format that I've specified. Remember the month and the time in the minutes, they are in the same. Okay, so month should be written in caps, capital MM, and time should be written in lowercase mm. See this distinction, please. Okay, so let's run it. Okay, now I'm going to run this for you. Okay, so that you can see how it is converted into a date field. See the separator also. See, I had the separator slash in my original string. Okay, I mentioned a slash here also, but by default it would always be converting into a hyphen. Okay, you can see the date now. See the things that are there. The date and time are separated as a date, and then a t is there, and then some time is there, and a time zone is there automatically. Since we are in India, so the time zone becomes plus 5:30. All right, we'll have a pause of a few seconds, please. Okay, I'm back. Okay, so just see how interesting this becomes. I've just given the char field and the format. Now it is converted into a date. You can see the date. The separator would always be a hyphen. Okay, the format has been specified by you itself, and then the date and time are separated by a capital T, and then a plus a time zone is there, which is 5:30 right now. So if you have a database from some other country, then automatically the time zone would be picked up automatically. All right. So let's change it a bit. Let's see whether we can have a changed format. Let's use this format now. I hope everything is fine. DDMM, yeah. Okay. Let's dump T to see whether we can have a variation. No. We cannot have a variation. Sorry, we cannot have a variation because our data set, as you see here, why this query didn't work, because our data set is not matching with it. Our data set, this one, our data set is not matching with this query, because in our data set it has to match with it. So if your data set is in this format, then you can use this format. Okay, I'll show it to you after some time. I have another file in which I've kept date as first, then month, then year. Okay, so let's work on this now. There is something which you need to know about the for each operator. That's very important about it. Okay, so this one we used, and then we dumped, because most of our date functions would be based on this concept only, right? Now I'm going to describe the relation D. Okay, so tell me, can you see automatically the serial number and DOB are picked? If I just change this query, this question to somebody who can answer. If I write this query like this, okay, and if I describe D, okay, what would be the syntax description for for D? Will it be the same as above, okay, or will it be just DT1 date time? Yeah, please answer this question. That would, strengthen your knowledge of for each operator. See the query that is written, for each Z generate this. I'm just generating to date, okay. So will Z contain only DT1 date time, or will it contain all the three columns? Yes, please answer somebody. Just need to make a guess, that's it. Okay, Ritika wants to answer. All right. Yes, Ritika.
So I think only one column.
Only one column. All right. Let's see. So whatever you project goes to D, right? Projection, whatever you are projecting is now being converted into a new relation and being stored in D. So obviously, if you need to, use the entire data set, then you must project all the columns like the ones we did here, like this. Okay. So we'll do like this, and if we describe in this way, we can use everything from our original relation Z, but the date changed to the char array DOB changed to DT1. And this DT1 is the thing that we want to work with, all the date functions. Okay. So let's now see these functions now one by one. First one is the current time. Okay. How to use current time? Let's see. So we have for each, we have the relation R for each D, generate this. Now we can simply write DT1 because, and see, current time has got nothing to do with your date stored in the data set. Current time is simply like this. Okay, now let's dump R. I'm going to display from my relation D, the serial number, the DOB as a char, and then DT1 is my DOB as a date field, and then the current time also. 4 things would be displayed. Kindly have a look at this. So you can see the current time is 10:47, 49.795. See the precision of the time, the milliseconds. It is hour, minutes, and seconds. So 49.795 milliseconds. Okay. Just have a good look at it so that you can extract other things also. That's why I'm saying, okay, one more thing. I just wanted, I've not checked it myself so far. So let's check it whether this date time goes without time also. Can we just go with the date? Let's check that. Okay. For this, I'll just change something from my A1 file. I'll just remove this time. Okay. I'll remove this time. Okay, I'll remove it and I'll just save it as A1. So this data set is now there. Okay, we would like to check whether we can convert it. So let's first load it. Because if we are having data sets which is simply having dates in some format, then can we work with this date time feature of Pig? Let's check that. Yeah, let's load A111. Let's use ZZ for this. This is the first step. Yeah, let's convert it. Yeah, this is the one. So we can use a DD for each ZZ, generate this. And let's just give this format, okay? Let's see whether it picks a 0000 time itself. No. We made some mistake here. Yeah. Okay, let's dump it now. If it picks, that would be good because usually we'll be having data sets with dates only. Mostly they are with dates. Specialized ones are with times also in that format that is specified here. Let's see whether it attaches. No. Some problem. Let's see what that problem is. Oh God. Can somebody tell me what the problem is? I found the problem actually. We didn't store this file. It is in our local file system. We used the local file system, so it is there. So it needs to be transferred to your distributed file system. That was the problem. Let's now run it again. We need to go through all these steps. This one, for each, this one. Let's hope it works. It should work. Should have 000 as the time should be there. Then it would be easier. Yeah, that's fine. So we can use this. This is good news for all of you. Like you'll be using the date fields in there. So the time you can extract all the date information, and if you pick up some good data set in which time is also there, then you can use both the features. But otherwise, a date can be extracted easily. The date information. So if it is all clear till this point, you can give me a raised hand. If you want to say something, like if somebody wants to, because I normally keep you muted and ask you myself. We have understood the date, this thing. Now we'll be working with all the date functions. Won't take long. All right, thank you. You are a wonderful audience. It's a real pleasure, teaching you all. The only concern is that whether you are trying your best to focus and understand this concept, because I tell you time and again, it would be useful later on. It's not a theoretical concept. It's something which is good for you. Okay. You can lower your hands. If you need to speak out something, then only you should keep your hands raised. Okay. Yes, Ritik, Shaurya, you still raise your hand? Yes, Shaurya? No, Shaurya is also gone. All right, fine. All right. So we have understood that we can convert a date, a string, into a date field, and then we can extract anything that we wish out of it. Okay. So this is how we do it. Okay. Char field should be there. Whatever character information you have, which looks like a date, which must be converted into a date. And here you must mention the format in which your char is there. Okay. So in our file, the year is first, month is then date. Then we must write this. Okay. And if time information is also there, then you should write something like this, as we wrote in our earlier query. This is regarding the time information: hours, then minutes, then seconds. Okay. And you can give it an alias also. It's easier to refer through alias as dt1 : its type is date time. Okay. So our relation now is D, on which we can do some projections. We already did, I think, with the current time. Let's just go through that again. Where is it lost? Gone. Okay. So let's use some more functions now. Relation का नाम ही भूल गया. D, serial number, DOB, and DT1. Yeah. So we'll be now doing all our date functions based on DT1 column of relation D. So I'll follow it up with like something T is equal to for each D generate, say, serial number, comma, I'll go with the first one as current time. So I'm just generating serial number and current time. Okay. So current time has nothing to do with DT column. Okay. Because that is DT column is a specific date. Current time picks up the time from the system clock. Okay. So it will display all the 6 rows will have the current time. Okay, you can see the current time now is 10:55:24. Okay, let's now expand this query. There is a function get day. Keep on noting now what these functions will do. So get day will pick up the day from the date. Okay, so as you can see in the first date, the day is 29th October, right? So it will pick up 29 from there, like this. Okay, oh sorry, that is the current date, that's not from the data set. So we'll see the data set. It will pick up the dates, the day from the date from the data set. So see the output to check. I just missed adding the DT1. That would have been good. This won't be a meaningful output. I'll just change it. Instead of current time, I'll write here DT1. So I'm displaying the serial number, the dates, and the day out of the dates. See the output now, it would be good. You can see now from 26 September 1989, it has extracted 26. Okay, so you could have a query something like there is a a shopping mart is there. So query would be there, see how many people purchased items between 20th and 23rd of some month, right? Okay, so then you can use a query like where get day this is equal to 23 and this, like between something like some query like this. This is one of the possible queries which you can pick up from a date. Then another one could be a get month. Okay, so let's expand it here. I don't know whether get month is there or not. I hope it is there. Let's hope it works. Get month, so it will pick up the month part out of it. Let's see whether it picks up an integer or a char. Picks up the integer part. Okay, so 26 is the day, 9 is the month, 20 is the day, 6 is the month, and so on. Okay, let's now add one more this thing, a get year sort of thing. Get year from DT1. So it will just complete the picture. Okay, so you get this information. So these are the basic functions. Let's now have a look at all our functions. The list is quite long. Current time, get day, get hour. Okay, so from the time you can get the hour, you can get the minute, you can get the second, you can get the millisecond, and so on. Okay, let's try these. Maybe I have some script for this. Let's see, shell gedit d1. Yeah, I've written some script for it, so I'll just make it minimal so that it's clear. Yeah, get day. Yeah, I want to discuss this also. Fine. Let me close this. See, please pay attention, all of you. I did this in 2 steps. First, I used a relation like this. I'll take some time to reach there, so please wait. Yeah, say my original relation was Z, so I converted it into a new relation D and used, now I'm using the date functions on D. I can do it directly here also. Suppose I want to get day, right? So I can use it like this, like the way you do, in one step you do things. So that's it. Okay, you can do it like this also. What I'm trying to do, from my relation Z, I'm generating 2 things, serial number and date of birth. I can just generate this only, serial number, and I'm extracting the day out of that string. So I convert that string first into 2 dates. So both the steps are there in one query itself. Okay, there's some problem. Please help me to answer what is missing here. 1, 2 brackets are okay. 2 date DOB. Kindly suggest what we are missing. Z is having this SNO. Yeah, Ritika wants to help me. Yeah, Ritika, go ahead.
So I think get day is returning an integer.
So it is not picking date time, data type.
No, it is, there is a date within it. So 1, 2, I'm just counting the parentheses, they are fine. You see, if I don't write a get day here, I don't write a get day here, right? What it returns, this would be a date, okay?
Yes, sir.
Okay, so I should be able to do it here. इसको रहने देते हैं. It's not making any difference actually. It should get the result, but why it didn't work with the aliases as? It will give the days.
So that will return int now. So schema should be int.
Okay, let's do that. We tried this. Let's just leave it like this. Yeah, true. I think that's a correct explanation. Just give it as name as dt1, and the type of dt1 will be automatically int. That's correct, Ritika. Good answer. So if I describe here the schema D, I'll have dt1 as int. That's correct. That was a problem. We were trying to get day was returning an integer, and we were trying to give it as a date time. That was a problem. So if you want to work fast, then maybe you can combine both the steps. Instead of taking 3 relations, you can just work with your original relation and a projected relation. Okay. The same way I have written something here. So I'll be checking those queries with you. So I'm writing here for each Z is my original relation, which contains serial number and DOB. So I'm converting that DOB into a date here, okay? And then I'm extracting a day, the minute, millisecond, second, hour out of it. And I'm using all these variables, day, minute, the operator, relation names, okay? So I'll save it and I'll run it, okay? I'll just say run D1. So it is running, you can see it has run all the queries, okay? Now you can dump whatever you wish. If you want to see the milliseconds in the date, so you can dump that, say dump. So I think it will return all zeros. Maybe something that I have added contains some milliseconds. So say dump milli. Let's see what it shows you, the milliseconds out of the date. Most of them would be zeros. Yeah. Milliseconds are all zeros. Okay, so let's get the seconds. Most of the seconds are also zero, hai na? So let's get the second part here. What seconds? So we'll have 0, 0, 44, 0, 0, 44 now. Second is not there. Maybe seconds is there. That is also not there. Sec is there. Okay. I hope you're getting what we are doing. We are just running the various functions, extracting information out of our dates. Somebody is asking something. Yes, Raju? Raju, you can unmute yourself.
No, sir. By default, it has gone, sir.
Achha, theek hai beta. Okay, no problems. Okay, so we see that we can extract information. I just used this script. Okay, you can see now. Okay, get millisecond. This function would return the milliseconds from this. Get second, get hour. So these are all the date functions based on, when you have a single date. Okay, let's now see where we have more than one, date, the functions which do some comparisons or arithmetic on dates. Okay, similarly there is get week also. Okay, get week returns the week of a year from date time object. Get week year returns the week year from the date time object. So you can see the differentiation. Okay, I leave it to you. I'll ask you in the next class. It says get week and it says get week year. So you should see the difference between these two. I'll ask you in the next class. Okay. Then another thing is add duration that I'll do at the end of today's lecture. And then we have certain functions which require, 2 dates, like days between, hours between, milliseconds between, minutes between, months between, seconds between, weeks between. So you see so much information you can extract. Okay, so let's check a few of these. Okay, the date functions which require 2 date fields. Okay. For that, I have got another data set with me in a format of DDMMYYYY. Okay. See it on screen now. A data set with 3 rows I've chosen. See, now the dates I've put in the other way around. DDMMYYYY. And the second date also, 2 dates are there. There's one serial number, there are 2 dates. So we'll store them as D1 and D2 say. Okay. So let's load this now into a relation E. If you are understanding, like, no response from your side or no question means that everything is good. So if everything is good, you are understanding the date functions, because you see, I discussed this with 5 CSE1 also, that in all probability your final exams would be online. All right. They would be tough, that I can guarantee you. Won't be like an assignment that you solve. You know how you solve your assignments and you send it to us, right? That online exam would be generating questions to each student in a randomized way. Each student will get different set of questions. There's a big database with us. Okay. So from that randomized 40 questions would be coming to each one of you. Different questions, good questions. Okay. So you need to be good enough, to answer them. So for this paper, big data analytics, whatever we are discussing, similar questions would be there. There would be data sets would be there. Okay. And the queries would be there, and you would be asked just to tell what would be the output of this particular query, something like this. Most of the questions would be like this. So theoretical questions would be less there. So kindly pay attention. Even if you have missed certain topics, you can just go to my channel and view all the videos. I put it date wise, lecture 1, lecture 2. So you can always learn from it again. That's my request to you, right? So let's load it here. File name is 82. It's in the HDFS also, I suppose. Remember this data set, we are going now to check the date functions which contain 2 dates as arguments, not a single argument, 2 arguments, both as dates. Okay. As I can give a schema here, int, comma, D1, char array, comma, D2, char array, right? And let's see the schema for E. It's okay. Let's dump E to see whether all is good with our data set in shape of relation now. So we can see now the simple 2 dates in char format. They're not yet converted into dates. So let's do the conversion now. Okay. So let's use a relation F to do the projection and the conversion of relation E. So generate, let's say SNO, comma, DOB, comma, then a 2 date conversion. And the first date is D1. Remember the format now is in capital, month in capital, Y, then HH colon colon SS. Okay, this would be this argument. And let's give it some alias as DT1 colon date time. Okay, as DT1 colon date time. Repeat for D2. This. Kindly see that there is no error, otherwise we'll waste time. All is good. Yeah, date time. There's some problem again. Yeah, there's a lowercase 2 date. Yeah. Some problem again. Yeah, we used DOB as a for previous example. we can do D1 comma D2 here. Yeah. So let's now dump this so that we can see that the conversion is good for both the dates, and then we can go ahead with the comparative functions of. You can see now the two dates have been converted. You can see the original char, which is using slashes, and the dates which are using a hyphen by default. Okay. So keeping in mind, are we okay with the dates 1910, 1990, and 1910, 19 and 11? Okay, fine. We're good. Let's pick up the first function. Say days between. Okay, days between the two dates. I'm going to write a query for this. Y is equal to for each f generate say serial number comma dt1 comma dt2, the two dates, and then days between. The data is there in front of you. You need to give me an answer for this. Okay, days between as days. What should be the answer? I'm looking for an answer for the third date. Okay, you can see the third date. I'm trying to find the number of days between the two dates that I mentioned in the third tuple. Okay, so some of you can try this. You should try this, some of you. Come on fast, we have some more work to do. Two dates are there in the third tuple. You can see we are going to calculate the days between, what it would return, and be careful in answering that. The dates are 19th October 1990 and 21st November 1990. What's the big deal about it? Can't you calculate the number of days between these two dates? No, nobody is willing to answer. So shall I dump the output? The same thing happened in 5 CSE1 also. I'm hoping somebody from you can answer this simple question. Okay. Ritika, as usual, wants to answer. Yes, Ritika.
So 33.25.
33.25. आपने ये 0.25 कैसे calculate किया?
So 6 hours थे तो 1/4 of a day.
Okay, Ritika, we'll pick up the answer as 33 or 34. Leave that. Negative or positive? You've done SQL days between function also. Like, would it be dt1 minus dt2 or dt2 minus d1? dt1.
dt2 minus dt1.
ऐसा होगा? Let's see. I think it would be a minus here. Let's see. Because first date is lesser, okay, the second one, so dt1 minus dt2, if it goes, it would be a negative one, I suppose. Negative. Otherwise, if it is like the other way around, it would be a positive one. Yeah, it's a negative one. So remember, it is the first minus the second. Okay, so it should be dt2 minus dt1. Okay?
Yes, sir.
And it has rounded off, like you said, 33.25. Okay, so maybe if it would have been 33 point, more than 12 hours, maybe it would have been 34 also. Okay, all right, so this is how we can calculate these functions. Let's pick up another one. Say let's pick up months between. Okay, let's see what it returns here, because it's not the complete month, I suppose, whether it returns integer or. So let's use months between. The dates are in front of you. This is it. So it is what, 21st November and 19th October. Your month is there, more than a month is there. So let's dump it and see. Let's see the last tuple, all of you. See the last tuple. So it returns 1. Okay, we can't be sure about that, so just let's change our data set a bit, okay, so that we are clear about it. How many days are there now? Okay, 4th October to 21st. Okay, 1 month, 15 days हो गए ना ज़्यादा. Let's see whether it rounds up to 2 or keeps it as 1. Okay, what I'm trying to do is I'm looking for months between, and the difference here is like it's more than 1.5 months. So will it round it up to 2? That's what I'm trying to check. A lot of work needs to be done here. fs hyphen put hyphen f a2 to root, right? That's done. So load these files again. This is the loading. Then the conversion when f for each yes. And then that is the query. Let's dump y now to see, whether it returns 2 or keeps it as 1. It keeps it as 1. Okay, so if the full month would be there, only then it is going to do it. Okay, it's the 4th October and 21st November. It is 1 month and 17 days. Okay, but it is giving it as 1. So it needs to be a full, for it to give it a, if it is 1 point something, it will pick up the lower value. All right. So this is regarding these functions. You can check them on your own, right? One more thing is left, one more category of function, that is this function, add duration and subtract duration. Okay, so let's see what they mean here. See the add duration, it needs a date time and a duration object. Okay, so it says returns the result of a date time object along with the duration object. Returns the result of a date time object along with the duration object. Let's see what this duration object is. Let's go to the website. See carefully now, we need to read something. So the syntax is add duration, we need a date time object and a duration object. And this duration, this is represented in ISO 8601 standard, in which there are certain terms where P is placed at the beginning. There is a character P which is placed at the beginning, which represents the duration. Okay, like what we are doing here is we are adding a certain specific duration to our date. Maybe some projection that what sort of things would be there after 3 months. So we need to add 3 months to our date, something like this. So this add duration and subtract duration functions, they help with that. Here P is, this duration object, this begins with a P which indicates the duration and is known as a duration designator. Okay, and then Y is the year designator. So if we write P1Y, that means 1 year. Okay, if I write P1M, it means 1 month. Similarly, see here, if I write PT1M, it means 1 minute. See the distinction here. PT1M, this means 1 minute, and P1M means 1 month, like this. Okay. So for this, to explain this to you, I have made another data set for all of you. Have a look at it. So let's just display it for you. Can you see I have the same 3 dates, but I have the duration object also. So if I use the add duration function, then 1 month would be added to the, 1 minute would be added to the first date. Can you see PT1M? 1 year would be added to the second date, and 3 months would be added to the third date. Okay, so let's load this into some schema here, some relation. Say V is equal to load slash A3. This is in HDFS, I suppose, as serial number, okay, as SNO:int, then D1 colon char array comma duration colon char array. So this is a schema for us, okay, for Y. You can describe Y to see the schema properly. Oh no, sorry, it was V. Yeah, it was V. And then you can dump V to see whether we can see this data set correctly, and then we'll use the add duration and the subtract duration functions. So we can see this, the date, the text is there, char is there for the second and the third fields. Okay, let's now convert this, say B is equal to for each V generate, let's generate all the things, SNO, comma, we had D1 I suppose, comma, DUR, comma, to date, D1, comma, what was the format? YY hyphen DD, then HH colon MM colon SS. This is the conversion as DT5 colon date time. Yeah, that's fine. Okay, and let's dump B now, and then we'll do the add duration. Now we have the B relation in which we have a date and a duration. Okay, you can see the duration and the date. So what I'll do here is I'll use the add duration on B, right? So let's use Q is equal to for each B generate DT5 comma DUR comma add duration DT5 comma DUR. Now I'll just check the syntax whether it's correct or not. Yeah, the same one is correct, I suppose. Let's dump it. Remember what it will do, you can see the dates on screen. To the first date, it will add 1 minute. PT means time, P1 simply 1Y is year, 3M is months. Okay, so let's dump Q here to see whether this add duration is able to add the duration to the existing date. So you can see here the time here in the first date is 9:00, 9 a.m., right? And here it is 9:01. 1 minute has been added. Here the year is 1980, and here it is 1981. Okay, the added 1 year has been added, and then 3 months have been added here. So that is how it works. Similarly, we can work with the subtract duration also. We can work with subtract duration also. And then we can dump, we can see whether we get 8:59 there as a time. So you can see 8:59 as a time here. Okay, and we have got the year 1979 here, 1 year is subtracted, and so on, right? Okay, so this is regarding your date time functions. So now we have covered the eval, the string, the date time, the arithmetic functions. We have also learned about the big architecture. Okay, so if you have any questions, you can ask. Otherwise, we can go for our last poll. The poll is in front of you. A simple one, I suppose. Closing the poll in 5 seconds now. The simple question doesn't require so much time, even with our network issues that our students are facing most of the time. For any problem that you have today, the solution is network issues, right? Okay, closing the poll now. Sharing the results with you. 90% of you are correct, 2 arguments. So minutes between, obviously we require 2 arguments, 2 dates. So that is the correct answer, 2 arguments, okay? So that is regarding the poll also. Now, any questions from your side on today's session? If you need to ask anything, any function which you want, me to discuss. Otherwise, what you can do is you can just go through the video. You must go through. That's my request to all of you. Like if there are network issues, this video would be available on YouTube on my channel. Go there and watch the video. What's the problem? Yeah, you need to invest some time in watching the video. You can fast forward it where I'm asking questions or where we are getting outputs. But you should, you should be watching this video. And all the videos that I've uploaded, they are for you. What is the fun? The videos, all the things, they are for you to learn. Okay. So let's ask somebody, let's ask Navjot Kaur whether she's still with us. Navjot, unmute yourself. Nikhil, unmute yourself.
Yes.
Nikhil, have you understood whatever you have discussed about the pig functions?
Yes, sir.
All right. Let's ask Rohit now. Yes, Rohit, unmute yourself.
Hello, sir.
Hello, how are you, Rohit? Have you
Fine,
understood?
sir.
Have you understood today's session, Rohit? Especially
Yes,
the
sir,
date
I
time,
need to practice.
especially you need to practice. That is the right thing. You need to practice, especially with the date time functions, how to convert a character into a date. And then obviously your part B would be
Yes,
a
sir.
great thing. You can extract so much out of your date. You can write very good queries based on that. All right. Thank you, both of you. I think on that note, I'll end today's lecture, and I'll be putting this video on YouTube. You can watch it from there. Thank you very much.